Acceleration calculation practice worksheet. So, when it comes to acceleration, you really need to have lots of practice doing the calculations. This is where you're definitely going to see at least one question like this in the CBA. So, problem solving process is set up so that we're going to do it this way. Question number 1, calculate the acceleration of a stop car that speeds up to 21 meters per second in 48 seconds. Any number, write it down with its units. Okay? Meters per second measures velocity, seconds measures time. Alright? Then, what's the question asking? Calculate the acceleration. That's your question. Now, in order to do acceleration, we need two velocities. We only have one written down. So look for the word stopped or at rest. There we go, stopped. That means we have a velocity equal to 0. Alright? So now we just have to read the question carefully to figure out which velocity is initial and which one's final. So, calculate the acceleration of a stopped car that speeds up to 21. So first the car is stopped and then it speeds up. So there's your initial and final. Acceleration is the question. So do I need to rearrange the formula? No. Okay. Plug in the numbers. Final velocity, 21, minus initial velocity, 0, divided by the time, 48 seconds. Okay. Have that all set up. Remember, parentheses around that. You must do the subtraction before. You must do subtraction before you divide. 21 minus 0 is 21. 21 divided by 48. Calculator says 0.4375. Significant figures. That has 2 and 2, so I want 2 in my answer. So we're looking at the 0.4. That 3 is going to round up because of the 7, so 0.44. Units of measure for acceleration are meters per second squared. There is your answer, 0.44 meters per second squared. I recommend as you go through this, you go through each question. So I would pause right now, try and work this question, and then put it on, see if you did it right. Okay? And go through it question by question. Depending on the rhythm of the class, you might need to do it a little differently. First and foremost, the most important question, most important step is step 1. Okay? Most important step is step 1. So here we go. 82 meters per second. Meters per second measures velocity. Okay? 1 minute 23 seconds. That's measuring time. Okay? Comes to a stop. Alright, so we have a velocity of 0. Now, notice here, 1 minute 23 seconds. Hopefully, you thought, wait a second. That's not okay. That's not. We need that all in seconds. So if there's 60 seconds in a minute, 23 seconds, it's going to be 83 seconds. Okay, that's going to be your time. Question is asking for calculate the acceleration. Okay, so if acceleration is the question, we do not need to rearrange the formula. We can skip that step. Alright, if you need to, pause here. Okay. So acceleration is the final velocity. Oh, which one's final, which one's initial? Go back to the question. Calculate the acceleration of a plane flying 82 meters per second and comes to a stop. So which one was first, the 82 or the 0? Well, 82 is initial, 0 is the final. So final velocity of 0 minus initial velocity of 82 and divided by 83 seconds. Okay, remember you need to subtract those first. What's 0 minus 82? That's negative 82. Negative 82 divided by 83. Calculator says negative 0.98795, blah blah. 2 significant figures in our answer. So it's going to be a negative 0.9. That 7 is going to round the 8 up to another 9. So negative 0.99. Meters per second squared, units for acceleration. Okay, next question. 4.32 meters per second, that's a velocity. Negative 0.75 meters per second squared, that's meters per second squared, is acceleration. Okay, stop, so the object is stopped, so we have a velocity of 0. And the question is asking for calculate the time. The question is time. Alright, so if time is the question, we need to rearrange the formula. Okay, this one we can actually put into the triangle under one condition. The VF and VI stay together. So they stay together. Notice they're on top in the formula. So VF minus VI on top, T on the NA on the bottom. Change in time is the question, so you cover it with your finger. T covers with your finger in the triangle. You end up with VF minus VI over A. So final velocity minus initial velocity over acceleration. Now we'll plug in our numbers. Final velocity initial. Ooh, which one's final, which one's initial? Go back to the question. Calculate the time it takes to stop a wagon moving 4.32. So it's moving 4.32 and we want to stop it. So this is the initial. This would be the final because that's the end result we want. So final is 0, initial 4.32. So final 0 minus 4.32 divided by the acceleration negative 0.75. 0 minus 4.32 negative 0.432. And we're going to divide that by a negative 0.75. And the calculator says 5.76. Significant figures, we want, this one has 3, this one has 2, so we want 2 significant figures or answer. Okay, 5, 7, 6, we want the 5 and the 7, the 6 rounds the 7 up to an 8, so 5.8. I'm solving for time, so my units of measure are going to be seconds. 5.8 seconds. Okay, next one, 2.79 meters per second squared. Meters per second squared measures acceleration. 4.5 seconds. Seconds measure time. Stopped. That means we have a velocity of 0. Okay. And what's the question asking? Calculate the final velocity. So final velocity is the question, that 0 must be my initial velocity. Okay? If final velocity is the question, I need to rearrange the formula. Again, I can use a triangle so long as I keep final initial velocity together. Okay? So final velocity minus initial velocity, keep them together, equals, cover with your finger, A and T side by side. Alright, acceleration multiplied by the time. So plug in numbers. Final velocity minus initial velocity 0 equals the acceleration 2.79 multiplied by the time 4.5 seconds. Okay, so 2.79 multiplied by 4.5. Calculator says 12.555. Alright, significant figures. We're going to want just 2 because of the limitation on time there. So 13, that 12, 5 rounds up the 2 to 3. 13, solving for velocity. Velocity is our question. So velocity is the question. Units of measure are going to be meters per second. Okay. On to question number 5. Like I said, pause is needed. Okay. So 15 meters per second. 83 meters per second. 29 seconds. Okay, meters per second is velocity, meters per second velocity, seconds time. question, calculate the acceleration. Acceleration is the question, no need to rearrange. Plug in the numbers. Oh wait, we know which velocity is which. So calculate the acceleration of a truck traveling 15 meters per second, speeds up to 83. So 15 is the initial, 83 is the final. There we go. So acceleration is the final velocity, 83 minus initial, 15, divided by 29 seconds. So to put this in the calculator, make sure you subtract those first. So parentheses, 83 minus 15, end parentheses, divided by 29. And the calculator says 2.3448 blah blah blah. Significant figures, we want 2. The 4 leaves 3 alone, no rounding, so 2.3. And units, acceleration, meters per second squared. Number 6. 103 meters per second. Stopped. 2 minutes 13 seconds. Okay, 103 meters per second, that's a velocity. So which one happened first? Because we have two velocities there. Plane is flying 103 and comes to a stop. So the 103 is my initial, the 0 is my final. 2 minutes 13 seconds, that should cause you to think there. 2 minutes is 60 plus 60. And then 13, so 60 plus 60 plus 60 plus 13. $113 seconds. That's your time. And the question is asking to calculate the acceleration. If acceleration is the question, I don't need to rearrange and I can just plug the numbers. Final velocity 0, initial velocity 103, divided by 113 seconds. Okay? So 0 minus 103 is negative 103 divided by 113. Okay? Negative 0.9115. Now emphasize the negative means that it's, if you go back to your notes, negative means it's decelerating. Alright? That negative means deceleration. Okay? Deceleration. A plane that's flying comes to a stop, it's decelerating, it's slowing down. So that's what the negative means. Alright. Question number 7. 7.35 meters per second, negative 1.24 meters per second squared. Okay, stop, so velocity equal to 0, meters per second velocity, meters per second squared acceleration. Okay, and the question is calculate the time. So time is the question. If time is the question, we need to rearrange the formula. VF and VI on top together, T and A on the bottom. T is equal to VF minus VI over A. Plug in those numbers. Oh, which velocity happened first? Okay, so calculate the time it takes to stop a bicycle moving 7.3. So moving 7.3 is my initial, and then I bring it to a stop. So that's going to be my final. So 0 minus 7.35, divided by, remember, check those first, divided by the acceleration, negative 1.24. So in the calculator, 0 minus 7.35 is a negative 7.35. Divide that by a negative 1.24. Calculator says 5.927. So significant figures, 3 and 3. I need 3 in my answer, so 5, 9, and 2. The 7 will round the 2 up. So 5.93, solving for time, seconds. And last but not least, we have 4.91 meters per second squared, 4.25 seconds, 25.9 meters per second, and the question, calculate the initial velocity. Okay, meters per second is velocity, so that must be my final velocity. Seconds is time, meters per second squared is acceleration. Alright, this is my question, so I need to rearrange the formula. Final velocity minus initial velocity, acceleration, and time. Keep those together. Final initial velocity equal to A and T side by side, multiply them. Plug in the numbers. Final velocity 25.9 minus the initial velocity is going to be equal to 4.91 multiplied by 4.25. Okay, so this one algebraically, it needs a little bit of effort there, but go ahead and multiply those. 4.91 multiplied by 4.25. So you end up with 25.9 minus VI is equal to 20.8675. Okay? We need to know what VI is equal to. So what number, when you subtract, so 25.9 when you subtract a number gives you this. So basically you need to subtract these two numbers. Okay? So 25.9 minus 20.8675 calculator says 5.0325. Significant figures 333, so 3 it is. 1, 2, 3. 5.03, and units of measure, we're solving for velocity, so it's going to be meters per second. Okay? Calculations like these are going to be on the CVA. There you go.